So Peter is a registered nurse and senior systems clinician at interRAI Services Te Whatuora. He's has in-depth expertise in the interRAI data life cycle and is contemplating postgraduate digital health studies. Welcome to the University of Auckland. With a broad interest in data collection. Now, I think we have to move the slides along like that, Peter. So with great glee, I'll hand over to you.
Thank you. Thank you for the introduction. Yes, I just finished my postgraduate diploma end of last year. So, kia ora koutou, I'm Peter Tang from interRAI Services, and thank you for having me today. And what I'm sharing today is not a finished product and not a promise of a new feature. It's a way of thinking using AI as a discovery tool to help us find new useful signals in the interRAI data. That's kind of signals that could complement the caps and outcomes and strengthen how we notice risk and support people earlier. In space exploration, sometimes we work on assumption. There might be something undiscovered, like a planet, a signal, or even a civilization. So we use different tools method to explore, and we don't expect to find something immediately. And we accept a lot of false start. I think interRAI data is similar. There are likely patterns we have not noticed yet, and such as early signs of decline, hidden subgroups, or combinations of factors that lead to poor outcomes. With AI, we could explore those unknowns more systematically. We might not find something straight away, but if we do, it could help us design better prompt services and earlier support. So we already have strong tools like CAPS, outcomes, scales, trends report, and they do an excellent job of describing what the map we already know, the one above the water. But those tools are by nature designed around what already agreed is important and measurable. They're the known territories. What I'm interested in is what sits beyond that map, the one under the water. Patterns that are real, repeatable, and meaningful, but not yet obvious, not yet named, and not yet translated into something that's easy for people to act on. So the approach is very simple, and it's a deliberate cautious. First, discover. Use AI machine learning methods to explore the patterns that humans don't easily see by eyes and with single variable analysis. Second, translate. Anything we find must be converted into a plain language logic, something clinicians and teams can understand, challenge, and validate. Third, governance. Throughout the whole process, we treat it like any clinical indicators. We test it, we document it, we monitor it, and we keep the option to stop it. The key point here is the output isn't AI decide care. The output is, here's a pattern worth reviewing, and here is why. Here's one example of kind of things AI might help to discover. Sometimes our attention is put toward single scales alert, one score changes, one threshold is crossed, and that can be useful. But real life does not always move in big steps. A person might show small shifts across domains. A bit less mobility, a bit more fatigue, a bit more care strain, a bit less appetite. And each change alone looks minor. But together, they can form a meaningful pattern that signals higher risk. AI has a capacity to help us identify those combinations and the trajectories. Then our job is to translate them into something safe and usable. Not a black box, but a clear pattern to watch that prompts earlier review and support. If we go exploring the new signals, trust is everything. And that means having boundaries we won't cross. We should use structured interRAI items and derived scales only, no free text. We should avoid black box recommendations and keep output explainable and auditable. Most importantly, this is human in the loop. A discovered signal that would prompt review, it should not make decisions. And we need to make equity seriously. If a signal behaves differently across groups by ethnicity, age, sex, reality, we don't hide that, we investigate them. And we keep a kill switch. If it's add noise or increase inequities or can't be explained, we stop it. So that's the logic. AI in this context is a discovery mission, not to replace caps or outcomes, but to complement them by helping us see what we're currently missing. And the main value of being here at this forum is that the room has practice wisdom, research experience, and operational reality all at once. So I close my presentation with 3 questions. What unknown unknowns do you suspect are hidden in our IntRAI data? What would make a newly discovered signal trustworthy enough to pilot? And what should output land first, research, quality improvement, or clinical prompt? That's my presentation. Thank you.
Very thought-provoking. Okay, questions from online or comments from in the room? I think there's heaps of things that AI might discover in IntRAI patterns, because you've got a nice longitudinal data as well. So you've got small changes over time as well as patterns within one point in time. Handing to Nikki.
Yes, just first of all, a question. Would you need to have an enterprise AI model that was entirely contained for safety? Is that the plan? And would you just set AI to look for patterns that were sort of not noticeable rather than have a hypothesis, because it will pick up things that we may not even have considered?
I think it could be either ways. So if you do supervised machine learning, like say, give the AI the data, they learn from the data, and then they provide some output. You can feedback to say whether it's right or not. Then if it's not right, you kind of provide feedback. If it's positive, they keep going. If it's negative, they move to another direction. But another way is like just let them do it and then find something currently not noticed. Yeah, could be either way, or could be both.
Sue.
I think this is a no-brainer, to be quite honest, that there is so much data there. So last year we had 2 honours students using LLMs to look at the malnutrition cap. So I'm still on malnutrition here. And they turned up, it was quite limited because we had to develop a model within the data. So they had to exclude those known variables that we know are risk factors.
Yeah. And
it started turning up other things that we needed to be thinking about. Things that were on our earlier model that we knew were determinants, but perhaps aren't looked at in the IntRAI so much. So I think there's certainly unknown unknowns, but you don't know those until you find them. So
yeah, I agree. Because actually, as Nara mentioned, because currently the caps and outcome scales are based on a single assessment. But again, over the journey of all the people, they may have multiple assessments of the same type and different type. So basically, this should be some missing signals, at this stage, because again, you may from acute care to context to home care to long-term care and then to the palliative care. During the whole process, I think this should be something we have not discovered. And AI should have the capacity to do that.
Would you, you said you wanted to identify those who had high risk of decline. So will you tell the AI to identify those who have decline over a period of time and then look back at their characteristics, or do you want to talk a little bit more about the methodology that you might use?
Again, this is going to be a very tricky one. Depends on how we're going to do this. If we're going to only look at IntRAI data without any external data linkage, you'll be limited because you may not know the health service encounters and also the outcomes of the patient, because you may not know that whether this patient is still alive or not. And look at the IntRAI data itself, I think because of the variation in the frequency of the assessment, there could be some issues there because, home IoT service is more frequent because, admission and then 6 monthly assessment. But for home care, especially across the country, there's a big variation around the standard. So, yeah, so because of that issue, there could be some issue with that, even with, with AI. Because again, the data we feed them is their food. The output will come from the food. So if we have some data quality issue or equity issue there, well, the output will have some equity issues there as well.
Could you use linked data?
Potentially.
I was just thinking about layers IDI. Could you do AI in the IDI? Sue thinks they already are.
There are aspects of it, I think, that are being used.
Yeah. Do you have questions for us, Peter, that you're particularly interested in this wonderful group of allied health assessors, interRAI experts?
I feel like this idea has been with me for years, but again, previously in the past, if we want to do this kind of approach, it's going to be quite labor intensive. But with AI, I feel like it's a good opportunity now because it's more efficient to do this piece of work. But again, for me, this is just an idea sharing at this stage because there's no work planned yet. At least from current, at this stage, there's no work plan for this. But I feel like there's a great potential for us to look at the whole data pool. Yeah.
Nikki, I'm interested in your question about the enterprise approach. Is that about privacy and safety? Hang on a minute.
Yes, that's a way of having an AI which doesn't take any data outside. And so you know that anything you enter is only accessing your data and only feeding back to you. So it is a privacy protection.
It'll be local. I think it'll be local training for this because of the sensitivity and privacy issue. It's going to be a local training. Yeah, it's not going to be like ChatGPT or Google ones.
University of Auckland uses Copilot and it's in its own environment and
Yeah,
just inside the university, can't go out.
Yeah.